G'day guys, today we're looking at something that's actually quite interesting. We're going to be having a look at solving circular functions equations that actually contain hidden quadratics. That is, they're comprised of circular functions, i.e. sine, cos and tan. However, these equations contain a squared form of either of the three, and therefore it's necessary to use a quadratic method to solve. And the interesting thing about these is they quite frequently appear on exams, and for a lot of people, it can be easy to get caught out because, admittedly, it does look quite foreign if you haven't seen these sort of problems before. However, once you know the method, it's actually really quite easy. So it's something that you really want to have in your repertoire going into an exam because of the fact that if you know how to do it, it is basically just free marks that most other people will get wrong. Now, just for starters, just a bit of notation. I want to just state that if you ever see sine squared x or cos squared x or tan squared x, you should know that that is simply the trigonometric function all squared. So sine squared x is sine x all squared. Now, moving on to actually giving one of these problems a go, we're going to have a crack at this. Sine squared x plus 2 sine x minus 3 equals 0, and we're solving with the values of x between 0 and 2 pi. Now, just looking at this, it probably looks a bit strange. I mean, if the squared wasn't there, this would be quite easy. You just add the signs, maybe chuck the 3 on the other side, and then you just get to solving quite quickly. But the issue is, because we have a squared there, we run into a bit of problems. But probably the easiest way to fix this is to actually let sine x equal something else. Because when you let sine x equal another variable, it'll just make the whole problem look a lot easier. So what I'm going to do is I'm going to write let u equals sine x. Right? So we're swapping sine x for a variable called u. Doesn't matter, you can call it a, b, whatever you want, just not x. So we're going to let u equal sine x. And then what we're going to do is we're going to rewrite this with u. And you'll see that it actually looks quite familiar when we do this. We end up with u squared plus 2u minus 3 equals 0. And all of a sudden, what have we got there? Well, we've got a very simple quadratic. And looking at that, it looks a lot simpler to solve. So let's just go ahead and solve that, right? And best way to do it, you could use quadratic formula. However, we're just going to jump straight to using factorization. So when you factor that, you'd end up with u plus 3. And you'd also end up with u minus 1. Right. Now, this is where we have to be careful because we're going to end up with two solutions for u because we're going to be solving it now. So we're going to get u equals negative 3 or 1. Negative 3 or 1. However, we have to think, can the output of sine x ever be negative 3? Well, it can't actually, can it? Because the sine function output is restricted to values between negative 1 and 1. Therefore, although u ends up equaling negative 3 when we solve this, sine x does not actually equal negative 3 ever. So we want to actually write sine x does not equal negative 3. Right? And then what we want to do is we want to move on to writing sine x equals 1 and then solving from there. Okay, so sine x equals 1 and the values of x we're looking for are between 0 and 2 pi. Now to do that, probably the best way to do is just draw one of these up, and of course because it's sine x, we're looking for, when sine x is 1, we want it to be right up here. So between 0 and 2 pi we'd end up with just one solution, and that solution would be x equals pi on 2. Alrighty, that's all done. X is pi on 2. So as you can see, how we ended up solving this problem the most effectively is because we let u equal sine x, therefore making our lives a whole lot easier, because it's a lot harder to work with sine x because it looks a lot more foreign to us, and I think it's likely that you might make more mistakes trying to use the next method I'm going to show you, which is not using u, but I'll show it to you anyway. It might work for you better. It's faster, but I would recommend only using it if you're really sure you know what you're doing. So we're now going to move on to trying it with cos, and we're not going to use u in this case. We're just going to do it factoring directly with cos. And how we're going to do that is we're going to write up the equation firstly. So we're going to end up with this. We're going to be try solving this. Cos squared x plus 7 cos x 7 cos x plus 6 equals 0. And what we're going to do is we're going to say for this one, x is an element of negative pi to pi. Alright, beautiful. So, what we're going to do is, instead of actually using u substitution here, we're going to try solve this by just directly using cos. So how we're going to do that is we're going to say cos of x plus 6 and cos of x plus 1 are our two factors, because we have to treat cos of x like the variable that you normally would in a quadratic. So how we're going to factor that is we're going to get cos of x plus 6 and cos of x plus 1 equals 0. That works because when we expand this, we will end up with what we had above. Now, we can just jump directly to solving here because we didn't have to use u. And once again, we're going to have to think, can cos x be negative 6? Well, it can't. So we're going to write cos x does not equal negative 6. And we can't proceed there to find any solutions for x. So what we're going to have to do is continue and try solve cos of x equals negative 1 and see where we end up with solutions for x there. So cos x is negative 1, and we're looking for solutions between negative pi to pi. Cos will only be negative 1 when we're over here, and over here that'll be x. We can either go all the way around this way, or we can go all the way around this way. So we're going to end up with x is negative pi. Let's draw that a bit better. We're going to end up with x is negative pi and x is pi. Alrighty, that's it. We've now solved circular functions equations with hidden quadratics using two methods. Essentially the same, really. There's not much we're actually doing different, but it's more just a matter of letting u equal a trigonometric function, or any variable, for instance a, b equaling trigonometric function. We do this to try and make it cleaner. As you can see, u squared plus 2u minus 3 looks a lot simpler, and it looks a lot closer to home than seeing something like this, which can be quite daunting. But anyway, ultimately something that looks quite difficult, but once you know the method, really not that bad at all. So that's all I have for you guys today. We're on about 400 subs at the moment, and I'm going to start grinding out a lot more videos because I want to help everyone and just provide videos to you guys who need help with whatever you're doing, programming, maths, whatever I can help with. So I really appreciate if you guys could chuck us a subscribe, just because you get notified whenever I upload a new video, and I'm going to be uploading a lot of them and trying to help you guys out as much as you can. Best of luck with everything, and I'll see you all later.